Welcome to lesson number 3 on the factorization of polynomials with 2, 3, and 4 variables. Today we'll focus on factoring polynomials with 2 terms. We will cover 3 main methods. First is greatest common factor, second is difference of squares, and third is sum or difference of 2 cubes. Difference of squares factoring must meet these 3 specific criteria. It must be binomial with 2 terms. Both terms must be perfect squares separated by a subtraction sign. Then identify the perfect square, find the square root, and plug into the identity. Let's factor x squared minus 9. Step 1, break the terms into the smallest factors as x squared equals x times x, and 9 into 3 times 3. There is no common number and variable in both terms. Since there is no common factors, you look for a special factoring pattern. The expression x squared minus 9 is a binomial with subtraction sign, and both terms are perfect squares. Identify a and b. We identify a as x and b as 3. So we can apply the difference of squares identity to get the factors. The factors of x squared minus 9 is squares x plus 3 feet times x minus 3. In example number 2, we factor x squared minus y squared z squared. The terms are perfect squares with subtraction. Applying the identity, where a equals x and b equals yz. Step 1, break the terms into the smallest factors as x squared equals x times x, and y squared z squared into y times y and z times z. There is no common number and variable in both terms. Since there is no common factors, you look for a special factoring pattern. The expression x squared minus y squared z squared is a binomial with subtraction sign, and both terms are perfect squares. Identify a and b. We identify a as x and b as yz. So we can apply the difference of squares identity to get the factors. The factors of x squared minus y squared z squared is x, plus y times z times x, minus y times z. For example number 3, factoring 9x squared minus 16, we find it's a binomial with perfect squares and subtraction. Here, a equals 3x and b equals 4. The factored form is 3x plus 4 feet times 3x minus 4. When factoring x to the power of 8 minus 9y to the power of 4, we apply the difference of squares identity. Here, a equals x power 4, and b equals 3 times y power 2. Plugging these into the format gives x4 plus 3y2, x4, 3y2. We then observe the second factor can be factored again using the same identity. 3 is not a perfect integer square. By using the square root of 3, it follows the same pattern. X power 4 is x2, 2, and 3y2 is square root 3y2. x4 plus 3y2 becomes x2 square root 3y, x2 plus square root 3y. Now let's look at factoring cubic polynomials with 2 terms using the sum of cubes and differences of cubes formulas. Example number 1, factoring x cubed plus 3 cubed. We use 3 main steps to simplify and factor the polynomial. Step 1, break terms into smallest factors. X cubed is written as x 3 cubed is written as 3, 3, 3. After confirming no common factor, we apply the sum of cubes identity. We identify the base values a equals x and b equals 3. There is no common factor, and we can use identity. a3 plus b3 equals a plus b, a2, ab plus b2. x3 plus 3 equals x plus 3 by 2 to 3 x plus 32 equals x plus 3 by 2 to 3 x plus 9. For example number 2, factoring 8x cubed minus 27, we step 1, break the terms into the smallest factors possible to determine the GCF. 8x3 equals 2, 2, 2, 2, xxx. A equals 2x. 3 equals 3, 3, 3. B equals 3. Step 2. Identify the GCF. The largest number that divides all the coefficients equals NA. Variable with the smallest exponent equals NA. Step 3. There is no common factor and we can use identity. A3 plus B3 equals A plus B, A2 AB plus B2. 8x3 plus 3 equals 2x plus 3, 2x, 2 to 2x times 3 plus 32, equals 2x plus 3, 4, by 2 to 6x plus 9. Example number 3, factoring x to the power of 6 minus y to the power of 6. We break down the terms into smallest factors. x6 equals xxx, xxxy6 equals yyyyy. And after confirming no common factor, we apply the sum of cubes identity. We identify the base values a equals x and b equals y. Apply the difference of cubes identity, resulting in x minus y times x squared plus xy plus y squared. If you found this video helpful, please like and subscribe for more content.